Okay, okay. Obviously, we are back, and this time the motive is not the same thing. It's not a normal video. Today, I have an exam tomorrow, and I'm not able to study. I don't know why, and I got like 400 pages to read, and the only thing I know is that I read really good when I actually stream myself. I don't know, somewhat it gives me some kind of push, right? Okay, what's happening to my mic? Why isn't it working? Hello. Okay, that's weird. Bro, please work. I can't fucking do things without you. How do this be? Performance mode, filters. What's wrong with this? Okay. Where do I do this thing? This is weird. Oh fuck no. Delete it, I guess. Filter, remove. Yeah. Remove. And then let's add it again. Audio input. The fuck is wrong? Yo, bro, please. Hello. It worked. What the fuck? Hey, finally. But we got a problem. Filters, edit filters. Add a filter. Noise suppression. And hello. Hello. This is fucking awesome. Okay, that's not good. Add good quality కావాలి నాకు. Better. Next, we got noise gate, compressor, expander, limiter. We got limiter, and we also need expander. Yep. And put them on the normal things. Compressor, and all right, all right. Everything's set. Oh my god, I'm sleepy already. We are just getting started. So let's just put it in here, and yeah, this is what we are going to do today. This is business analytics, and this is business data management. These are the two things that are going to be studied today, and these are just the transcriptions of the lectures that are on YouTube already. Not transcriptions, summarizations, right? We got a feature on YouTube of Ask AI, right? I just used that, and I gave it a prompt and it gave me this summary. and we will use this summary to actually prepare for the exam because we don't have notes. We didn't prepare anything. We don't even know the name of the subject till now. Anyways, let's get back. BA, Business Analytics. I'm very interested in this subject, to be honest, but I have never actually listened to this class because I was too busy. Now let me get my water bottle. Let me get coming to my speaking skills. They are fucked up again. I need to start from the scratch, and I'm ready to go from next year because this year I'm ending with a developer role as well as a marketing guy because I'm not a marketing guy. To be honest, a developer role, a developer role as well as a designer role, right? I'm a designer as well as a developer for that app, and that's what I'm focusing on this year. And the most important part about this thing is it was really hectic because I never built that type of technology before. It's a new technology for me, so I have to start, by learning it and then using it on the same time. And I have done it, right? But my expectations are very high at the beginning. I thought that I will be ready with an MVP in 2 days and I'll make the app, you know, a functional app in like what, a week or two. But what happened is that the MVP did not come out till 1 month. The learning curve was high, and then there were so many errors, and there was a lot of planning being done. There were like hundreds of iterations of the system design or the prompt and the agents that are supposed to be there in there. The orchestration of the agents have been tweaked a lot of times, and yeah, that's what happened. And what it took for me to get an MVP is actually more than a month, right? More than a month, 1 month in, and I could get one feature of my app working, and it worked properly. It beat all the competitors, like in terms of the speed, in terms of efficiency, in terms of how the prompt is, right? So it's I didn't name the app yet, so I can't tell you what it is. But yeah, and then it was started in September, I guess, and then I got my exams here from midterm exams, semester exams, and then I got exams from a different degree. I had to prepare for that, which I didn't yet complete. Tomorrow is the last exam, which is the final exam. I have a complete syllabus, same day with all the subjects in. It was hard, and I also had projects from this college, which I had to complete and give viva and do other tasks, and I have done them too. And I was in that, I couldn't get much time for this one. So I paused it and then I proceeded again with the new features. What happened is that I fucked up the whole system architecture because what I figured is that I have done beginner's mistakes in designing the system because I never actually worked with that technology. I didn't know what it could be doing or what are its strengths and weaknesses. I didn't check into that. That's my mistake. I should have done it before I actually planned the system architecture because I didn't know that it will not work that way, right? So for an extension, there are like infinite, infinite risks of losing your data, right? Everything under that app, everything that happens under that app will be visible to the user because the extension actually runs not on your server but in the browser, right? On the client side. So I didn't know that. I didn't know the clients get to access all the information. And what I had to do is completely convert from one, the TypeScript or JavaScript framework into Python framework after building a whole freaking, yeah, I built a whole freaking feature. What happened is, first I have used LangChain in TypeScript, and I've built the agents, right? A huge agentic cycle. I've completed it, and I tried to run it. What happened? It failed because apparently this LangChain framework is actually dependent on Node, and Node.js or Node server is not actually available in browsers, right? It doesn't run that way. Browsers is only client side, and they can't run servers. So what I had to do is that I had to convert that LangChain. I have deleted that LangChain because LangChain has dependencies of this node environment. So I removed it and added my own orchestration. So I designed my own workflow. So removed all the things that LangChain gives us, all the abstraction, and made it build my own LangChain, to be honest, to be simple, right? From scratch without any abstraction. And it worked well, right? It was successful and everything. Then what happened is that one thing came into mind, that how do I deploy this? And I made a Google account and all that. After that, I realized after a lot of iterations, improvement of the bug fixes, and all those things, I had to actually do authentication, and I have done it. I have done authentication, use Superbase, and I have done it. It was perfect. But the problem is, I've used environment variables, and those environment variables are actually visible in the browser, and that gave me a heart attack. That's not how it's supposed to work, right? Environment variables are supposed to be secret. And I went to Google and I asked about it. And apparently, browser doesn't actually hide anything from the user. Every freaking line of your code will be visible to the user. Every freaking variable, every freaking thing that you do will be visible to the user. And hence, if you have any proprietary code or any of your secrets, you should put them on the server. And that server will be hosted, and this one will be connecting to that server via webhooks or WebSockets, right? And then I had to plan to actually build that thing in the server. I built it, and then I also have to construct how to actually refactor from the UI from this one into API keys, right? Actually, do client side is doing every work, and I have to remove all that thing and replace it with AI. I mean, it, REST API, right? REST API. But then I've done that. I've done that, and everything was working fine, except I had to spend a few more months refactoring it, breaking my brains, and there's a lot of bugs. The most important part is that my cursor tokens have been completed, or just completed. I have overused them, like about $10. I had to pay extra from for next month, and that freed me out. Uh, and I got broke. I mean, not in terms of money. I was broke already. I was broke in the terms of passion, right? So it's actually burnout. I've been working too hard on doing this, and it has kept failing and failing and failing and put me down. But yeah, I have learned really valuable lessons, right? From the next time, I will not design a system without knowing its strengths and weaknesses, without knowing it properly. From the next time, I will put security in my perspective, because I took security for granted, right? Because websites that I've been building, they didn't ask for, all I did had to do is put them in environment files, and I knew that they will be safe. This is not the case here. They are not safe. and hence I did the right thing. There is also the problem of storage, right? I have to manage how the storage is getting created because these can't use cookies or get things done. I have to store stuff. We also have limited CPU assigned to these things, so we need to also be fast as fuck. And for that, we have to optimize our algorithms and system architecture. Had to do that as well with like so many iterations, and then I realized that the new feature will be needing not LangChain but LangGraph and this connection. I can build LangGraph agents easily, but problem is with the connections, right? The connections from front end to the back end, and that will be happening in the WebSockets. And how do I do that? How do I connect it? I don't know. So I had to research, and what happened is that I just let Cursor do the job for me. I just asked Cursor to actually put out a WebSocket connection, right? To open a WebSocket connection in Fast API using LangChain agents, and he did it. And he did not do good, obviously. It's not Claude Sonnet, and I'm not sure even the Claude Sonnet would do it better because it's a tough job, right? I should have just made it myself or gave it pseudocode for each file and asked it to actually make it reality. But instead, I just said, come on, build me a webhook, WebSockets connection with this URL. And these are the things, these are the messages of type of messages you'll be getting. And it's not that I have given very bad prompts. I have given like really good prompts because I've been working on improving my prompts or researching about prompts since months, right? And my prompts are almost perfect. Hence, even if that happened at that level, it failed. I gave it the resources, literally, I gave everything, right? And it failed. And the worst part is it's getting connected, right? But I don't understand what's happening because when I look at the code that it has written, it was like 6,000 lines of code, and I just can't get my mind around it, even to review it. So I just quick review, keep it, and I just committed it, right? Without reviewing it because it was too noisy. I didn't understand what's happening in there, but I just thought, let's give it a chance, and I did it. And it fucked up real bad. After that, what I've realized is that I got burnt out. I stopped doing it, and I also was designing the website. On the other hand, I've tried Framer, I've tried Figma, and failed miserably. I even tried Rive for animations. I did an animation, and what I realized is that I had to pay to actually export that animation. So I spent like 5 hours or 6 hours, not 5 hours, 8 hours. I spent 8 hours actually designing that animation, and it was so fucking good. And then I clicked on export. It asked for me. It asked like $30 from me, and I'm broke. I didn't expect this, and my 8 hours of work got wasted, and that was fucking breaking, heartbreaking. Anyways, after going through all of this shit, I got a burnout, and in this burnout, I realized that I spent way too much time and way too much money on this thing that have never thought of or even planned about. I never thought I would be logged in so long. And there is another problem with it that I just realized is that there are a lot of bugs in WebSocket connection because from there you can actually open a WebSocket port from the backend. It is easy, but the connection management from the front end, right? I can manage the database, the saving of the ports, port manager, all those things. But the point is, I didn't actually plan for doing this because what I Dead is every time uh active URL comes in, right? It will be checking the URL address, and every time it changes, it will be checking it. If the target URL is reached, what happens is the connection will be connected. But the problem is whenever there is a tab switch or minimizing of the app, what happens? WebSockets gets disconnected and it has to be reconnected again. That's a bug, right? It can be fixed actually because you're still on the tab. You can actually listen to the event of inactive tab or minimizing, and whenever there is the focus on that tab again, you can just connect it again, right? That is the best way, and it is also efficient because you don't have to stay connected to the server for long, and the server will be sleeping, right? It will take rest and save me some money. That will be good actually. I should implement that. Man, but I also want to actually remove all that fucking noisy code that it has written, and I want to write it myself, and I will write it myself. This is fucked up, bro. This is really fucked up. Fuck, I'm so sleepy. Anyways, today's agenda is not that. I just dumped some, feelings and status, right? So, business analytics. We have exam tomorrow. Let's start. A probability distribution is a complete description of all possible outcomes of an action or event, along with the probability associated with those outcomes. Think of it like a map that tells you what can happen and each outcome is. How likely each outcome is. There are two main types of probability distributions discussed. Discrete probability distribution used for countable outcomes, represented by probability mass function for a discrete mark. Okay, I need to save my energy for this. We have 400 pages to do it. So I should stop shaking my head, and I should also stop actually trying to sound cool with full of energy. I don't want to do that because I'll be tired within few pages, right? I will lower my tone, relax my mind, muscles, let the microphone do the job. Anyways, who's gonna listen, right? I don't care. Man, I don't know what I'm doing. If I there's no there's no other way, man. This is the only way I can get better. Things happen. Anyways, continuous probability distributions will be having a different range. They will be having values which are continuous instead of different chunks, and we'll be having a given range in which we'll be having frequency, so represented by probability density function PDF. So there are different types of distributions. So normal distribution, which is often a bell curve. So what will happen is that the things are in the middle more, not you go extreme right or extreme left, you'll be having less frequencies, and peak frequency will be in the middle. That's normal distribution. Uniform distribution, all values are in a certain range, have an equal probability of occurring. Using business data with distributions. empirical distributions. These are distributions which are built by directly from the data you have collected. And yeah, if you took the 36 months of sales data, you can directly use those to actually analyze the data, and that is called as empirical distributions. And advantage is that it is simple to construct, and it directly reflects the observed data. And the disadvantages and problems of that is that the range is restricted. You can't go over the 36, and there is also a range about maximum and minimum observed range, uh, you know, outcome range. So you can't go beyond them as well. And fitting a theoretical distribution. So what we do is take that 36-month distribution, see how it's turning out to be, and predict, and we actually fit that distribution into a theoretical distribution. So we have normal distribution, binomial distribution, uniform distribution, exponential distribution, and these other distributions can be compared with the distribution of the outcome we have and choose one of them which is really close to that, and find out the parameters of that function or the graph, and then you can actually expand 36 weeks 36 weeks into 10 years, right? That's the whole game in here. And you can also have different formulas to actually do things about it. You can try to find formula parameters, theoretical distributions, the data you do that generated values, okay, better testing, better rating, blah, 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 blah. Comparison of application approaches, empirical distributions, and fitting theory distributions. I don't care. So you just have to go ahead and calculate these things. Once you calculate those things, you'll be understanding what it actually is. So if all of them are equal, what happens? So if mean, median, and mode are equal, that will be a normal distribution. If all of these, and if this shit is zero, it is a uniform distribution. If these two are equal, it is a uniform distribution. Obviously, average. Right. Support is, yeah, graphical interpretation of the further clues. Box plot, bar chart, histogram. I mean, all they are doing is that they're plotting that shit inside graphs and analyzing these things, synthesizing cues, addressing the distribution. So yeah, what we do is clues introduces the coefficient of variation. So this might be, okay, it is sigma by mean, the deviation by mean. So what it means is that by how many times the deviation is, right? The deviation is more than the mean. That means that values are explosively moving, right? They are completely different from one another. So yeah, if it is close to one, that means if the standard deviation is equal to mean, that is a strong indicator for exponential distributions. Hmm. Fuck. I'm already tired. It's been 5 pages. Shit. I'll shit my pants if I can't do this shit. Oh my god, this isn't happening. I need to get this done. David Goggins. David Goggins. Let's do estimating parameters. Once the distribution is guessed, the next step is to estimate its parameters, and How will you do that? Maximum likelihood estimation. What we'll do is, again, does not go into the detail how to do it. So fuck it. Taking goodness of a fit. So if you have found a fit and if you want to check how good that is, so there are some of the tests like t-square fits and all those things will be coming up. So Mhm. How good is the fit? Exponential distribution. How do you test it? First, frequency comparison. So you just have to compare this frequency with the ideal frequency for that particular distribution. So you can find definitely differences between that and this, but the actually target is that you have to keep those changes minimal, right? The less the deviation from the ideal distribution, the more the fit is considered good. Probability plots, again, the same thing, right? Frequency and probability are often the same things, actually. Oh, gosh. Quantile plot. So it means it will be plotting quantiles. So, yeah, come on. Cumulative probabilities, fine. Because you'll be having, if you have cumulative probability, you'll be having the test of how things are working from 1 month to 2 months, and 1 month to 3 months, and 1 month to 4 months, and 1 month to 36 months. That way you can see the probabilities and you can actually compare it with the ideal version. If it works, then yeah. If it doesn't, then there is something internally which is actually tricking you to think that it's a good fit, right? Mm. Don't fucking do this, Banu. Oh. I don't know how I'm gonna do the YouTube thing next year. I got an year. I don't have to worry about it, but still, I'll be having things to do. A lot of things will go down. I know that. Sorry, I'm acting weird, but yeah, it's necessary. While visual tools provide insights and statistical tests offer more definitional conclusions, these tests check if the data is set variables are independently identically distributed. The test for independence of data. Square test. I'll only be working for like the next 5 hours. After the 5 hour, fifth hour, I'll be having to do with other subjects. Obviously, I'll leave this thing, and I can see that I've spent more than 10 minutes now, and I've read 5 pages. That is good. That is good. I hope I will go on that same pace. Anyways, T squared weakness fit is a test overview of purpose. Test fits the access. The purpose is the test helps to assess whether the theoretical probability distribution adequately describes an observed data set from a population. Requirements for performing the test. To perform the test, you need a frequency table which consists of three main columns. Bins, observed frequency, expected frequency. Bins are the ranges or categories of the data which is grouped. So you'll be taking the data and we'll be dividing it into some number of bins, and This will be a sequential cut, it's not a random cut. And we'll be having observed frequency. These are the column that contains actually counts of the observations. Expected frequency. This is the ideal thing. Computing the chi-square test. So it's computed by observed and expected frequency. So yeah, how do you test if the it is good or not? Obviously, we will go with frequencies and then probabilities. And here, chi-square test will always be testing frequencies, and that's fucking awesome since all you do is summation of deviation from the expected outcome whole square divided by expected outcome. This seems to be familiar. There is some function in statistics which looks exactly like this. What is it? Is it like squared of frequency deviation? It is, right? Standard deviation formula. It's definitely standard deviation. Oh, come on. So chi-square statistic is standard deviation from actually that thing. You so the less the deviation, the better it is. Oh my fucking god! If fucking doing this, compute p-value for the calculated chi-square statistic. Conclusion that if the p-value is less than chosen significance level alpha, you reject the null hypothesis. This suggests that observed data does not fit hypothesis hypothesized distribution. So p-value is actually maybe the probability value or maybe the answer to this shit. So you'll be given a significance level alpha, and if you actually have things less than that significance level, you reject the null hypothesis, which is actually suggesting that data does not fit the hypothesized distribution. So this should be less than that. Deviation must be less, right? I don't understand. Compare the computed T-square statistic with the tablet values from the T-square distribution table. So tablet values is defined for the degree of freedom, significance level, degrees of freedom considered as k minus p minus 1. P is the number of parameters of the population and k is the number of pins and 1 is the number of freedom loss. Number of pins, that means number of rows, parameters, and then there is the additional degree of freedom loss. If your chi-square tabulated value is less than your computed chi-square statistic, is the oh yeah. Number of parameters. The value of p varies depending on the topology distribution and weighing hypothesis. Uniform distribution will be having two parameters. Poisson distribution will be having one. Normal distribution will be having two. This should be low, right? Oh gosh. Oh god. Let's go. P-value approach. Compute the p-value for the calculated square statistics. The p-value is less than certain significant level. Then, oh fuck, I read it already. Goodness of it. Is for uniform distribution using Python. The lecture breaks it on the process. So first one is get descriptive statistics to narrow down the possible candidates for the population distribution, to use visual tools for the take the distribution, identify to the descriptive statistics matters for the visuals, and create the frequency table, make approximate appropriate conclusions. The primary goal is to demonstrate these steps on a Python tool, not to expose users extensive coding, although okay, loading unnecessary packages to the data on NumPy panels. Fine. Demonstrating the dataset using data inform, which is specially designed to form the data frame, MDF, length of the scratch, initial data visualization, histogram. Okay, matplotlib, that can be used. Okay, we got mean, standard deviation, minimum and maximum. Minimum and maximum are very similar, but mean, standard deviation are nice. Based on the statistics, we conclude that it's not a Gaussian normal for the supporting the idea of uniform distributions as an alternative. Yeah, further is visual checks. Check if the proposed observation is the tail proportions. If points fall at 95 degree, 45 degree situations, performing a t-square goodness of fit test. Null and alternative hypothesis. Null hypothesis is given the distribution actually follows uniform distribution. Alternative it does not. And creating frequency table, identifying bins of equal length, observing frequencies, computing expected frequency, performing t-square test, making conclusion, using p-value significance. You'll be looking at how did you find the p-value. P-value in this example is this. How the fuck you define that? I don't know anything. Let's just get through that. A Poisson distribution. Tutorial focuses on Bayesian becomes the continuous uniform distribution. Poisson is a risk distribution necessary approach to this condition when the mean calculated in the frequency is common. Business context for a Poisson distribution is containing defects in the product. For example, the example data sets containing the number of defects found in the 100 observations, data loading and initial exploration. Uh, Data Poisson data set is loaded using NumPy and Pandas. The initial histogram of the data is plotted and which might initially suggest a normal distribution. Descriptive statistics are the crucial when identifying a Poisson distribution. Is each law. What am I speaking? Test. Required priority packages are in SciPy. Mm-hmm. Unlike continuous distribution where data is split into bits with ranges, discrete distributions require exact values. Okay. Calculating expected values. Once expected subfrequencies are corrected, chi-square test can be performed using I2 contingency and chi-square value is 5.19, p value is 8. Whatever the fuck it is, I have no idea. Just change the topic. Right. Determining association between the categorical variables. The main goal is to determine if there is an association between relationship between two or more categorical variables. This is done by analyzing the sample data and generalizing the findings of the larger population contingency table. So it is a primary tool used to display the relationship between two or more categorical variables. It shows frequency distribution of the variables in rows and columns. Types of probabilities derived from the contingency tables. Joint probabilities refers to the probabilities of two or more events happening at the same time. In this context, the contingency table is probably the specific combination of categories. Notation P, A, and B. Marginal probability is the probability of single event occurring irrespective of other variables. Is found by summing up joint probabilities across the row or column. Uh, Conditional probability is the probability of an event. Marginal is single product. Conditional probability is the probability of event occurring given that another event has already occurred. It is crucial for determining the association. Notation P A or B, the probability of event A happening given that event B has already happened. P A by B is P A and B by B. This is Bayesian probability, right? Yeah. So we are finding different types of probabilities here. Introduction to Bayes theorem. Yeah, not Bayesian, Bayes. Huh. Anyway, probabilities, okay, posterior probabilities. What the fuck is that? Illustrative example, raw material suppliers. Scenario, manufacturer receives raw materials from two suppliers. Supplier 1 provides 65% of the material. Supplier 2 provides 35% of the material. Quality information, material from this one is 98% good quality. Material from S2 is 95% to understand how to calculate probability related to source and quality raw material. That's fine. Calculating joint probability. The video explains how to calculate joint probability. Formula for joint probability. Yeah, I know. Calculating the posterior probability using the Bayes rule. So again, we know this. So what are we doing? Supplier one and good quality. And what the fuck? So we are trying to understand what is the distribution like. It's all repetition. Okay, introduction to G-square test of independence is a statistical test used to determine if there is a significant association between two categorical variables. So if two things are independent or not. That's what you are checking. Customer preferences for brands are dependent on the city. So if you want to check if the outcome is actually dependent on the variables or the categories, you have to do this test. So frequency, the first step is to organize the data into the contingency table, and this table shows the actual counts of the observations for each combination of the categories. Steps for t-square test. Calculating expected frequencies. The t-square test compares the observed frequencies with expected frequencies. Expected frequencies are the counts you would expect in the each cell of contingency table if the variables are totally independent. Yeah. So p-value is the probability of obtaining test results as least least as extreme as the probability of obtaining the test results as observed results observing imaging our time distributed. That makes sense now. Significance value is the probability of predicting null hypothesis when it's true. Precision rule p-value is less than this. Then reject. Manual implementation. Okay, 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 okay. We got this. Okay, I'm not waiting for me or something. Type by stats. We're still recording. It's been an hour and we have done 30 pages. So it's going pretty on slow. We should actually start moving faster. Means variables are independent, we just gonna fuck off spreadsheets. I don't want to do these things. Degrees of freedoms is just remove the row -1, column -1. This is for actually checking if they are having columns relations, right? Okay. Rules implementation, demand response curve. So demand response curve definition, the price is on the x-axis, demand is on the y-axis. It shows us realize the demand is that given price offered, optimal price and optimal demand. So best price to offer, which corresponds to optimal demand in the market. Yeah, in demand. It refers to the potential for increased demand if the price is better. Consumer surplus, the benefit of the consumer gets by paying less for a product or service. If the price increases from P star to higher price, the consumer surplus is reduced rate away by the retailer. Retailers must carefully choose their optimal price. The main objectives are discussed: revenue maximizing profit maximizing price. The price at which the money collected from the customers is maximized. Price at which the profit is maximized. It's important to know that these two objectives may lead to different optimal prices. Non-negative quantity and price. Demand for the product is always non-negative. The prices offered are also non-negative. This means the curve is the first quadrant continuous curve. The curve is smooth and continuous without any breaks, meaning that there is a different demand for every price point. However, no way, no way. Smooth and differentiable. The curve is smooth, allowing for a tangent to be drawn at any point, indicating its differentiability, downward sloping. Generally, as prices increase, the demand for the product decreases. Exception luxury items. Measure price sensitivity along with this, using the slope. The slope of this thing will be price sensitivity. Obviously, negative price is measuring the price sensitivity using demand elasticity. Definition demand elasticity is defined as the ratio of the percentage obtained of demand and the change in price and difference from the slope. Unlike slope, which uses absolute changes, elasticity uses percentages. That's it. It's not statements. General representation of less elastic goods, more elastic goods, they manage this sensitive to prices, less sensitive to prices. Elasticity and time elasticity can also depend on the time frame, leading to short-term elasticity and long-term elasticity. Short-term elasticity very low because salt is immediately needed and there is no alternative. Elasticity may not change drastically as it remains an essential commodity. Wheeler short-term higher elasticity prices to go in one mile of alternate transport like a bus. Elasticity may decrease if the fundamental long-term demand provided. Low elasticity pocket. Why am I reading this? Introduction to demand response curve. Demand response curve illustrates the relationship between price and product, and the demand is generally a downward sloping curve, meaning it's a as the price decreases, the demand decreases. Demand increases. Obviously, market size is the maximum possible demand for the product, and price is zero, and the curve intersects at the demand axis at this point. Delineating price. This is the price at which demand of the product becomes zero. Linear demand response curve. Market size minus market size by satiating price. This is where the price demand is zero into price. So it's about ratio. The market size will be increasing as P approaches the satiating price. Yeah. Elasticity of the linear demand response curve, a satiating price, elasticity approaches fine non-linear demand response curves. Not always linear, the linear is constant. Elasticity curve. Revenue maximization. Revenue is calculated as price multiplied by defined demand. For a linear demand response curve, revenue curve is parabola. Maximum revenue. To maximize revenue, the optimal price for a linear demand response curve is half variating price. Okay, I'm going to do this. How many of the important properties of demand response curve? Downward sloping. Generally, demand increases when the price increases. As price increases, the change in demand due to the change in price is typically negative. Minimum price, satiating price. There's a minimum price and satiating price where demand drops. The relationship between the price and demand was previously established into four properties: non-negative, downward sloping, continuity, differentiability. Slope and elasticity are all ways to measure price sensitivity. Two types of relationships were discussed. A simple linear relationship where elasticity may not be constant, and constant elasticity relationship where non-linear, which is non-linear but maintains constant elasticity. In the experiment, different prices are offered, and the realized demand at those prices is measured. It's important to remember that the demand curves are non-negative, and with zero being the smallest observable value, the goal is to collect this kind of data. Variables in estimation product problem. Demand is considered the dependent variable in this reaction of the market. Prices are considered as explanatory variable. Objective is to estimate the slope and relationship between relationships and estimate. In a linear relationship between price and demand is desired, the focus is finding the slope. In a constant elasticity relationship is being fitted, the goal is to find estimate the elasticity from the data. So slope is different from the elasticity. introduction to simple linear regression. Simple linear regression is used to analyze relationship between two variables, specifically to understand how conditional mean of the different variables changes with different values of the dependent variable. So there is one independent variable and there is one dependent variable, and to see how conditional mean of different variable changes. Whole primary goal of SLR is to calculate the intercept, the market known as the market size or constant, and the slope. All right, makes sense. Fundamental equation for the relationship is beta 1 and beta 2. Y is the dependent variable, demand, independent variable, price. So demand depends on the price, obviously. And as the y-intercept representing the value of y, and x is 0. Beta 1 is slope, representing the change in y is equals to mx plus c. Let's try c. X plus b by plus c. Not really. Demand response for context. So since it's a straight line, that means b by is equals to mx plus c. And since you want it to be not a straight line, then we will having another fucking variable. Simple linear regression implementation in Excel. If we don't care. So, yeah, well, overall significance of the model. Can you hear me? And you can. Let me just. Okay, I can't do that. Very risky. I'll be right back. I don't know what I don't have to edit that. Oh, okay, I'm on live. Sorry. Mm. Mm. Good. Very, very. Mm. No, they. Oh, oh, fun.